Hi, I'm Leif Wickland. I have been doing Scala since about 2010. At the time, I was working for a company called the Rubicon Project. And I got to go off and build a system to count usage data for financial reasons. That company got bought by Oracle. I stuck around, did my time. I can promise you there's still Scala in production at Oracle because they need to count the money still. I moved to a company called Rubicon Project. I ended up doing something very similar there. I have the pleasure of doing all this from Bozeman, Montana, which is a lovely, lovely place. This isn't Bozeman, but it's similar. So what is static analysis? I think it's running software on your code to detect problems before you run it. To me, that sounds a little bit like what I want my strongly typed language to do for me in the first place. But really, this isn't quite the compiler's job. So let's go on a little bit with that. So the compiler's job really is to turn the code that you write into something that executes. And along the way, they detect some conditions that probably aren't optimal and you don't really want to ship. And they can report those to you. But by default, they usually don't. I think we should have coding standards. I think coding standards that are a dead document just sitting there aren't really coding standards. And I think if you want to have a real coding standard, you need to have that automatically enforced. I think code review is great, but I think we can automate a lot of that if we use static analysis well. So what you're going to get out of static analysis, what you're going to deserve, what I think we can deliver you, is a better compiler that causes you fewer errors and explains things better when you do mistakes. I think you can have more hygienic code that's more consistent, that's easier for your team to read, and doesn't allow itself to devolve into worse bad things of like infinitely long functions and gigantic classes. I think we can have higher quality code that doesn't let people coming into Scala fall back on the bad practices they learned from before. Null and var here. And I think we can ship fewer bugs. So I'll show you some examples of those coming up. So there are lots of tools that we can use for static analysis in the Scala ecosystem. I'm not going to give you all the details on all of these. I'm going to say some of these are good and some of these are better. But I want to point out before I start casting aspersions in any way that I'm really thankful that the ecosystem has all these tools. And express some gratitude before I start ripping things down. So moving on, your IDE probably has some ability to tell you that you're doing things wrong. So for example, if you are editing things in IntelliJ, it'll highlight things with a dark yellow color, and that's usually to tell you that there's something you're doing there that's suboptimal. I'm not going to talk about those very much because I don't really think that they are the tool that you need because it's hard to apply that uniformly. Now, when I was at Oracle, there were some teams that mandated everyone on the team use the exact same IDE, and they would do their static analysis that way, which I found sort of repugnant and repressive, and I hope you don't do that. And I also hope you don't build your releases out of your IDE. So I think that your tools for static analysis need to be independent of your IDE. I mean, they can supplement in the IDE, but we need something outside of there. There are some web UI tools that will do static analysis, and those are kind of nice if you have a mixed set of languages that you use. If you need a way to provide your executives some view of code quality across Python and Scala and all kinds of things, these can be helpful. The analysis that the Codacity and Scrutinizer have for Scala, at least last time I looked, was somewhat rudimentary, and they didn't have sort of that full suite that I want to do. So I'm not going to cover those particularly either, but they do exist. So for the things I am going to cover, let's approach them with these three criteria. How much reward do I get for using them? Is it giving me lots of false positives that waste my time and make my team angry? Or does it actually help me find errors that matter? Suppression, when it does find something and it's not actually a thing I care about, or I really, really do need null for some reason, is there a way that I can say on this one line, let me have my stinking null? I'm sorry. And how quickly can I get started? Can I get it integrated in my build quickly? And can people who see these errors easily move on, figure out what's wrong with them, and keep going? So here is an example of some Scala that doesn't quite do what we want. Can anybody tell me what this is going to do? It's going to print 0, right? This is not what we want in any way, because our friendly val a there gets initialized to b, which has a private backing variable that got initialized by the JVM to 0, and then eventually that thing got set to 42 later on. So this is not remotely what we want, and I don't want my compiler to let me do that. That's the reason I'm using Scala, not JavaScript, right? I mean, like, come on, let's do good things here. So the good news is that Scala 2.11 now warns us when we do something dumb like this. The bad news is that it's only a warning, and I can still ship it, and I don't want that to happen. I want to find out at compile time, not runtime, that I've done something stupid. So Seth recommends that if you've got a well-managed project, that you set X fatal warnings. Do you have a well-managed project? I mean, show of hands, like who has X fatal warnings on? Okay, not enough, right? Like this is a really useful tool that this compiler will give us. And this isn't the only thing that you'll benefit from there. So in SBT, you do something like this to turn on those warnings in a way that makes them not warnings, makes them errors. What does this code do? This code is always false. It compiles. We pass unit to equals. Equals says a set of 1 is not equal to unit. Right? This is not what I want to have happen. I want my compiler to tell me I'm wrong. What does this code do? Likewise, this code passes unit to set, to the apply method on set, and says false. No, there is not a unit member in that set. Again, I don't want this to happen. Scala deprecated this feature called adapted arguments around 2.10, but it's just deprecated. You can still ship this. You can still get baffled as all can be by these, this code that compiles and doesn't do what you want. So there's a switch, -deprecation, that will provide useful error messages, and when coupled with X fatal warnings, turns this bad stuff into an actual compiler warning that stops and lets you know that you've made a mistake. One problem with turning on -deprecation is it applies also to libraries. So if you go and upgrade to a new version of a library and they've deprecated some functionality, that will appear as a compiler warning. Now, maybe that is often what I want, because I want to find out that I really need to stop using that method, but it can also be a problem if you're in some horrible fire and you need to upgrade a library to work around a bug, and yeah, just something to be aware of. What does this code do? Yes, and when we run it, what happens? Yes, exactly. This code blows up when we ship it. It compiled just fine, but because the format method doesn't receive as many arguments as the format specifier has placeholders, at runtime it blows up. And this is probably the kind of thing you do in an error message. So the fact that you had an error and now you've masked that error by producing a new error is awesome, right? Just perfect. I desperately want this never to happen again. So the good news is Scala gave us string interpolation, right? And I love string interpolation because it makes it so much harder for me to make that stupid mistake. But the thing that happens to me is this. Now I ship this code, and my logs are now full of strings with $signs in them because I'm an idiot and I forgot to put an S on the left-hand side of those strings, so I didn't get string interpolations. I just got lots of money. And while I love money, I don't want the money in my logs. So good news. Scala will tell you when you do this stupid thing if you ask it to. It will report a missing interpolator exception in this case. To get that, you need to add a -x to your Scala C options. And then you'll have these lovely, lovely warnings. So xlint is kind of a big hammer. It enables a whole bunch of things at once. As of 2.11.4, you can get one at a time. You can incrementally enable them, which is really nice if you're trying to add this to an existing project that probably has some unfortunate mistakes. What does this code do? Does it compile? I mean, not in my project it doesn't. But sadly, vanilla, this project, this will compile. And I'll stick a integer in that sequence with those ADT members, which is not remotely what I intended to do. The compiler infers a sequence of any. And this isn't probably what I want to do. If it is, I'd be happy to tell it, yeah, I really mean that. So by Here's another way we can look at this same kind of problem. I can take the cross product of a sequence of integers and a sequence of strings and get out something nonsensical that is a mixture of integers and strings, right? And it'll infer it as any, which is good for approximately universal equality and universal toString, both of which make certain faction of our camp very angry. So if I want to prevent this from happening, I can enable xlint, and Scala will give me this glorious error message that says any was inferred. And the world is a much better place all of a sudden. So back to this. Go home, add those things to your project. You will find mistakes most likely, and if not, you won't make as many in the future. So on my delightful scale, I'd say that the warnings that Scala C gives you are really useful. There's no way to suppress these things, so I hope that that's just the way it is. And their documentation on xlint and so forth isn't fantastic by any stretch. About the only documentation is what you get off of the command line by passing -help Scala C. And yeah, I don't have a copy of Scala C sitting around because I just let SBT download it for me. So it's not easy to get to necessarily. One interesting quirk here that Stephen Compal pointed out to me is that if you are a library author and you cross-build for Scala 2.10 and 2.11 and 2.12 to help the community out, this can be a problem because the options for static analysis to Scala C are not consistent across all those versions. Well, the solution that somebody pointed out, I can't remember now, is that you just configure SBT to only apply those switches to the most recent version of Scala and don't worry about it on the other ones. All right. Other static analysis options in the JVM ecosystem. There's a thing called FindBugs. It's an old tool that came out of the University of Maryland. A guy made a plugin for SBT. It used to be that if you went Googling for static analysis for Scala, this is one of the things that would turn up. Don't do it. It's terrible. FindBugs is looking at bytecodes, and it sees the things that Scala C generates and just freaks out, dumps lots of error messages, and is totally useless. So the signal-to-noise ratio is real bad. Don't do it. Just walk away. Other options over in the static analysis world, there's a tool called Scala Style. As the name implies, it's kind of towards style. So it helps you go down that path of an executable coding style in a lot of cases. It's really easy to get started with. It's got a nice SBT plugin. The Coursera class that teaches Scala stuff uses Scala Style to add that extra layer on top of helping people write Scala in a functional way instead of Scala as a better Java. And it's a mature, well-documented project. The bad news is that to configure it, you end up writing a bunch of XML. If you're still with me, the good news is that we can incrementally change things. So it's easy to just have a config file where everything is disabled, add it to your existing project, add one rule enabled, and then periodically tighten the screws down a little bit. It's got nice suppression mechanisms where I can bracket a region with comments, turning things off and back on again. It's got a more concise form that you can use to do things like this as well. If I make broad sweeping strokes about the rule set that Scala C offers, I'll go with these three. So like I say, executable coding standard, I can put caps on how long lines and files and functions can be. I can keep cyclomatic complexity down. I can limit the number of arguments to a function. I can prevent magic numbers from appearing in my code. Like if I have a constant integer, I must assign it to a val directly instead of just having it appear in the middle of an expression. So that's nice stuff. I can ban people from using null, var, return, while, and calling clone. And I can encourage good practices like don't ship code that has public methods that aren't type annotated, right? Doing that, shipping public methods that aren't annotated is a good way to break your users later when you make a change inside and Scala C infers a slightly different type. So there's a lot of wisdom baked in here that this tool automatically gives you. So if you want to extend Scala Style to do other things for you, there are two different routes you can go. You can just write a regular expression to match code, and if that regular expression is found in your code, it freaks out. So one of those that I use is I say I don't want to see print line in my code when it goes to continuous integration. And I can suppress that in the few places that I need it. But in general, if we're wandering around adding print line to our code to like quickly figure out what's wrong, I don't want that to accidentally then get shipped. So this helps me. If I need a more complex custom rule, they have a way to do that. The API isn't awesome and the documentation isn't terrific, but it's possible. So the rule set's sort of broad. They'll cover both sides of a controversy. So if you want to have spaces around your operators, they can require that you do that. If you want to ensure there are not spaces around your operators, they can also ensure you don't do that. So yeah, it's a big bag of tools. So in general, I'm pretty happy with Scala style. Next tool I want to, So I think Scala style is useful because if your coding standard isn't automatically and uniformly applied, you don't have a coding standard. I think what you have is a vehicle for misanthropy. So when I've seen coding standards before, they're big, long, dead documents of bullet points, sub-bullet points, and sub-bullet points that only get referred to when somebody's angry at somebody else and they want to hit them over the head with it to make them do what they want, right? That's not what I want. I want just a set of rules everybody agrees to play by. So I think Scala style is useful for that. On the topic, I really like Scalera form. It's a tool that automatically formats your code. I don't think you're a snowflake. I don't think I'm a snowflake, and I don't think my indentation style is amazingly better than yours. I just want us to agree that we're going to have consistent formatting, and we'll go with it. So I've been happily using Scalera form for a whole bunch of years, and everything ends up looking about the same because of that. There's a nice SBT plugin that you can use to either compile every time code changes or configure it differently to only run when you tell it to. There's also a new thing like this that I like a little bit better, but I haven't used in production yet, if you want to describe it that way, called Scala format. It's got a lot more advanced options. So one of the things that Scala style doesn't do is automatically wrap your code. Scalera form doesn't do that. Scala format does automatically wrap your code. It has a lot of neat alignment options. I'm a big fan of it. It also has an interesting option to run a command that just tells you whether your code is formatted correctly, which is useful for CI. So yeah, I would definitely look at this as an alternative to Scalera form if you were thinking about going this direction. Okay, another static analysis tool that exists is Abide. It started as a summer student project in 2014. It's owned by the Lightbend Typesafe folks. The bad news is it's never really been released. It's not a project that's reached critical mass, but it has a tremendous amount of potential in the sense that it has a really good architecture for analyzing code, and it can do so more quickly than some of these other tools that I'm talking about because it's built to make the analysis happen in fewer passes over the code. But you can't really recommend it because it's never been released. So it's got some interesting things, like unused local variable detection is a feature I really wish I had, and I don't think any of the other tools have that. And it would make sense for the nice folks at Typesafe, Lightbend, whatever we call them these days, to have this, because it means that you get to take some of that complexity out of Scala C that they're doing today and move it off into another tool so that they can innovate in Scala C faster. But again, there's not a community around this. So Adrian would be really happy if somebody would come along and help him build this thing up into something better. So I can't recommend it, can't really evaluate it, it doesn't exist, but it's close to existing, sort of. All right, what about this code? What does this code do to us? Sadly, this code compiles, and we get a sequence of product with serializable, which is one of my least favorite things to have in the world, because the top one is a 2-tuple, and the bottom one is a 3-tuple, and through the magical power of inheritance, those are the same kind of thing, and our type inference system says, yes, I can do that for you. Well, oftentimes if that happens, it's not what I want. Wartremover is a static analysis tool Brian McKenna wrote. It is accurate and well documented. It has a nice SBT integration. It will detect that problem that we just talked about. You can extend it in neat ways, and it has really good suppression options via an annotation for a small area or just exclude a file from analysis entirely. If I broadly categorize its rules, we've got these three. So problematic inheritance, like we just saw, if it ever sees the compiler inferring these things, it'll complain. Banning better Java, just like in Scala style, kind of the null, var, return and throw, or things maybe you don't want to do. And partial methods. These are things that if the object you're calling them on isn't in the state that you think it is when you call that, these will blow up on you. My team, we call these YOLO methods, right? Because if I call head on a list and that list happens to be empty, it's not that I get, oh wait, end of the world, right? An exception happens and we're done. So I don't particularly like those. Wartremover can help you teach new people on your team that that's not something that you want. So there's a lot of good things about Wartremover. It's sometimes kind of painful to use. The nice guys at Slam Data use it extensively and have almost all of the checks turned on. It's a really opinionated tool. Like if you're using Wartremover, it's probably because you're off kind of in that type level sort of mindset, and you're not at all in the kind of middling, it's okay to use vars from time to time place. So yeah, what does this code do? Does it compile? Yes, this code compiles. And when I run it with something that is not an array of 2 elements, it prints this delicious string down at the bottom, because we ended up calling the toString on array, which is not what you want at all. Does this code compile? Sure, that compiles. And we end up doing an order big O operation, first to check the length of a list, and then later again to reduce it. We can do better than that. And there's a tool over here, Linter, that will detect these things for us. So Linter started with Jorge Ortiz when he was at Foursquare. Jorge's moved on and done other things. There's a guy named Matic, who's picked that up, forked it, maintained it, added some additional things to it. The documentation isn't fantastic. It has lots and lots of rules that feel somewhat overwhelming. It doesn't have an SBT integration, so you need to understand how to pass compiler plugins through SBT to Scala C to use it. Like I say, it's a little bit overwhelming because there are just so many rules. They're not terrifically well documented, so a lot of times you're just reading the 80-character long name and trying to infer what it does. That's the downside. But I found it really useful when I ran it on my projects at work. It found a lot of different things, like that calling toString on an array that we talked about before, forgetting to close Scala sources, the aforementioned unnecessary linear operation on list. And a bunch of different places. When I first started Scala, I tended to do dumb things like call toSeek on a seek where I didn't need to. That kind of thing. So it found a lot of good things. It'll also help you stop using Java converters. If you're still doing that, stop as soon as you can, because they're going away. Hooray. Problems, like I say, it's got incomplete documentation. It does have nice suppression via comments. It's fairly slow. I wish that somebody would make a list of the highest value checks that we can get for Linter so that I could just turn on those things to begin with. And quickly figure out what value I could get out of it in a new code base. I wish there were an SBT plugin just to make it a little bit easier to use. So yeah, there's my summary on Linter. How could we do this better? Yep, exactly, right? Oop, I'm sorry. We could call exists on sequence instead of having to do that extra isDefine check. How could we do this better? Or at least differently. Yep, we can call contains there, and that'll help us find these things. So there's a tool called Scapegoat that will help you find those kinds of things. Stephen Samuel wrote that. It feels pretty mature. He's been working on it for a couple years. Hasn't done anything to it in the last 6 months. He has a nice SBT plugin. Good documentation, lots of ways to suppress stuff when it comes up. its rule set, if I were to summarize it, feels like everything I've told you about before mashed into one tool, which I already said that it felt like Linter was a little bit overwhelming. Now, like, we're really talking an overwhelming wall of, oh my gosh, I didn't know my code was so bad all at once. When I did run that, like, here are some additional things in my code that I found after I'd already run those other tools on my code. Yeah. So what I don't like about Scapegoat is that it just feels so overwhelming, and it has a few rules that I just disagree with. Like, I want to be able to say my case class is final in some cases, because usually it's not a great idea to inherit from a case class. I got quite a few different false positives when I tried it. So consequently, I say the signal to noise on this one is a little bit hard to deal with, because it did have some more noise, and yeah. So Scapegoat's interesting. It wouldn't be my first choice, but I'm glad it exists. What does this code do?
False.
False. Yes. Thank you, Java. Thank you. Because equality on arrays doesn't work at all. Oh well. So the nice folks that give us Scala test, Artima, have a commercial tool called SuperSafe that does static analysis. It costs $60 per user per year. It's about 2 years old now. They're coming up on a 1.1 release. The majority of things that it focuses on are problems of equality and inference. It has a pretty small rule set, and they have a really strong emphasis on avoiding false positives. Consequently, they've never bothered to build suppression. When I did find a false positive, I sent it off to them, and they fixed it right away. And it's a fast tool. So some of these others you don't really want in your main build. This is one that you probably could have in your main build. So because it's a commercial product, I want to hold it to a little bit higher standard. I don't somehow feel like it quite hits there. I don't know, at least the places I've worked, it's kind of a hassle to like jump through, not mentioning Oracle by name here, but Oracle, it's almost impossible to get, you know, some small vendor that you pay $60 a year to get a tool in. So it's kind of at that threshold of where it just doesn't feel like it's worth it in that way. Maybe it's easier for you to get that to happen. What does this code do? Yeah, it gives us a lovely string when we're done of a list with 3 tacked on the end, because anytime you do plus, in this case, you get string concatenation, and that automatic 2-stringing on the left there. That's not quite what I want. Wartremover will help you find this one. So in summary, I'd say go home, turn on those linty switches to Scala C as quick as you can. I think you ought to have a coding standard in Scala style that you automatically apply. My favorite ones here are Wartremover and Linter. You know, keep an eye on these other things. If you want to be a great member of the community, go help Abide out and give it some love. Here is the same sort of summary, but in even more colorful form. I've got my slides online that you can just come grab, so you know you don't have to take pictures. I mean, I can, but yeah, I'm real sorry about that. So greenfield suggestions. If you can, I've got a list of Scala C switches in addition to those 3. I stole them from our good friend Typelevel because he's amazing. And then I think I added a couple to them. There are Scala coding standards, and they'll help you, you can help enforce those with Scala style. And then I think it's useful to have a lint build target that you have in SBT where you use one or more of these other tools that I've talked about. And there are some slow Scala C switches like find unused imports that you probably don't always want to use, but would be nice to be able to have, you know, once in a while on your release sort of thing. So that might sound overwhelming. I made a skeleton project that I have up on GitHub that you can go grab that sets all this stuff up, and I've tried to make it easy for you to just pull those things into your project. If you have an existing project, you almost always are going to have to do this incrementally, where you figure out a way to turn on a small number of rules, maybe set some goals within a sprint, you know, convince your team that this has value, go clean some things up, and then keep iterating and making progress going forward. Once you've done that, you can't live with these errors. Like the reason that, these warnings. Like the reason that we want X fatal warnings is because I've seen a lot of projects in my career where people just ignored them, and you compile and you get hundreds and hundreds of warnings, and some of them are genuinely bad things that you don't want. And if you allow these lint tools to sort of step outside of your release pipeline, they just end up being noise. Because if it's not on that path, that gate that you have to go through to get to production, people will figure out some way to go around it. At least that's been my experience. So don't let that happen to you if you go to the effort of bringing this in. Figure out a way to make it a genuine gate to the process. If you get nothing else out of this talk, go turn on those 3 switches. Do you have any questions for me? Go ahead.
One minor gotcha with the Scala C options is that combination breaks the SPT console, because anytime you declare a variable, it's unused, and that's a fatal warning, so it doesn't compile. So you just have to also filter it out from your console options. But if you type SPT, the SPT Scala REPL, those compiler options don't work in the REPL.
I haven't had that problem. So to repeat what he said there's a caveat to using that set of options in the REPL within SPT, that as soon as you make a variable, it gets reported as a unused variable, which is fatal, and it won't let you do that. I'd be interested to see that, because I just haven't encountered that one.
It's an easy fix, though.
Okay. So then you're saying the fix is to exclude that from the arguments that get used on starting the console.
Right.
Okay, interesting. Anything else? Thank you.